Hi, today we are going to see BTech or BE, Basic Electrical and Electronics Engineering, previous university question papers, unit wise solved problems with explanation. Here the topic we are choosing is transformers. So first question paper is regular end exams September 2023. Okay, BTech second semester regular end examinations September 2023. Okay, here the subject name is Basic Electrical and Electronics Engineering. In this question paper they have given 3 pages of question paper. In this question paper 6th B we can find transformers problem. Okay, we are going to find that solution. Okay, so 6B, the EMF per turn of a single phase 2200 by 220 volts 50 Hz transformer is approximately 12 volts. Find the number of primary and secondary turns and the net cross sectional area of core for a maximum flux density of 1.5 Tesla. So here they have given the data, it is of single phase transformer. Okay, and 2200 by 220 volts, that is E1 value is 2200 volts and E2 value is 220 volts, frequency is 50 Hz and EMF per turn, okay, in the entire winding, okay, entire winding the voltage is 2200 volts and they are giving per turn, for one turn the EMF value is 12 volts. Okay, and to find number of primary N1 and number of secondary turns N2 and area of cross sectional area. Okay, they are asking us to find out area and they have given maximum flux density. So BM, maximum flux density, B or BM equal to 1.5 Tesla. Okay, the units for maximum flux density is either Tesla or Webers per meter square. Webers per meter square. Okay, so here we have given B and asking us to find out A. So where we are going to get these two? Phi value. Okay, maximum flux, the formula for maximum flux phi equal to Bm into A or B into A. Okay, from that we can find out. And here according to given data we are going to find out the transformation ratio. Transformation ratio K equal to, this is the known formula, so K equal to E2 by E1. There are many, that is transformation ratio K equal to E2 by E1 equal to V2 by V1 equal to N2 by N1 equal to I1 by I2. So in this formula we are going to take K equal to E2 by E1. So 220 by 2200 volts, that is K equal to 0.1. We got K value. After that, generally for finding N1, number of turns in primary, okay, here now we need to find out the number of turns. So where we are going to get N1 value? In the EMF equation of a primary winding. So E1 equal to 4.44 into F into phi into N1. If you observe carefully, we know E1 value, but we don't know, we know frequency value also, but we don't know two terms. N1 term we don't know and phi value also we don't know. That's why we are going for another way. That is, see, EMF equation for primary winding is, that is the, for the entire winding is 2200 volts. And here for one turn, okay, there are many turns, in that for one turn they have given the voltage, that is E average per turn equal to 12 volts. So we know for one turn the voltage is 12 volts and we know the entire winding voltage, okay, the number of turns, the total number of turns voltage we know, right? So N1 equal to number of turns in primary winding is equal to E1 by, that is EMF equation, that is voltage for entire winding by voltage for a single turn. So E1 by EMF induced per turn, that is 2200 by 12. So we know 1 turn voltage value, we know entire winding voltage value. So entire winding voltage by 1 turn voltage winding. So we are going to get total number of turns, that is 183.33. But the number of turns will be in without a decimal number. So we have to write a round figure, that is 184. Okay, so we are N1 equal to 184. So we got N1 value also. Okay, and next E2 equal to so 4.44 50 into 50, that is frequency, into 5 value. 5 value they have given. So 5 value is 1.5. Okay, why 5 value is 1.5? 5 formula is B into A. B into A. So B we know 1.5 into A. Okay, into N2. So here the unknown terms are A and N2. So according to transformation ratio, there is another formula, that is K equal to N2 by N1. So from that we are going to find out N1 value, because here so many unknowns are there, right? So we know E2 value, we don't know area value, we don't know N2 value. So find out N2 value. N2 value is K equal to N2 by N1. So here N2 equal to K into N1. So K value already we found. K value is 0.1 and into N1 value. N1 value is 184. So 0.1 into 184. For knowing better values, I am putting exact value, that is 0.1 into 183.33, that is 118.33. So round figure, it is of 19. So number of turns in secondary is 19. So N2 I got. So if you observe carefully, we got the formula. Okay, we know N2 also. So in this E2 equal to 4.44 50 into B value 1.5 into A into N2. So just now we have found N2 value. So the only unknown value is A. So A equal to 220 by, okay, E2 by 4.44 into 50 into 1.5 into 19. So we got A value also, that is 0.0347 meter square. Area, the units for area is meter square. So N1 we have found, N2 we have found, and A we have found. Okay, this is how we have to do the problem. Here we are going to see another question paper. In this question paper, it is of BTech third semester supply end exams, February 2023. The subject name is Basic Electrical and Electronics Engineering. Okay, here we are having 5B. We are having 5B transformer problem. So we are going to see here also they have given 3 pages of question paper. Okay, in this the 5B is a transformer problem. We'll see about that problem. So a single phase transformer has 500 turns in primary winding when it is connected to a single phase 120 volts 60 H power supply. The no load current is 1.6 amperes and no load power is 80 watts. Neglect the winding resistance and leakage reactance of the winding. Calculate the iron loss current IC or IW, the magnetizing current IM. Number 3, the peak value of the core loss, that is phi max. Okay, so they are asking us to find out IC or IW, that is we will be calling it as core current or working component. Okay, so in the formula I naught equal to IC plus IM, I naught equal to IC plus IM. So IC and IM are having separate formulas. So again we are going to see. So given data, single phase transformer, number of turns in primary is 500, N1 equal to 500, and frequency is 60 Hz, voltage is 120 volts, current, no load current is 1.6 milliamps, and the power is 80 watt, 80 wattage. Okay, the power is 80 watts. Okay, and find out IC, IM, phi m. So phi m value is, see where we are going to get phi m value, in the EMF equation. Okay, EMF either we can write EMF equation E1 or EMF equation E2. Okay, so here we have taken EMF equation of a primary winding. So E1 equal to 4.44 N1 F phi m. From that we are going to take this formula, that is phi m equal to E1 by 4.44 into F into N1. So what is E1 value? E1 value is 120 volts, where E1 equal to V1 for a no load transformer. E1 equal to V1. So E1 value, that is 120 by 4.44 into 60 into N1 is 500. So from that we got phi m value is 9.009 into 10 power minus 4 Webers. The units for flux is Webers. Next, IM value. Okay, IM value is I naught sin phi naught. The formula is I naught sin phi naught. So I naught value is 1.6, and sin phi naught value we have to find out. So here already we know the phi value, so put that phi value here. So 1.6 into sin 9.009 into 10 power minus 4. So in the calc if you put, you are going to get the value. So here the total value for IM, magnetizing current, is 0 amperes, and IC equal to IC or IW, working component. So IC equal to I naught cos phi naught. I naught value is 1.6 and cos 9.009 into 10 power minus 4, that is 1.6 amperes. So in this previous paper there is one more problem, not only 5B, there is one more problem, that is 4B. 4B also there is a transformer problem. We will see this transformer problem to find maximum efficiency. Okay, so 4B, the maximum efficiency of a 10 kVA 500 by 5000 volts. Okay, so kVA rating they have given 10 kVA, that is 10 into 10 power 3 volt amperes, 500 by 5000 volts, that is they have given E1 value and E2 value. E1 value is 500 volts and E2 value is 5000 volts. Single phase transformer is 98% efficiency. Okay, 98%. So the maximum efficiency is 98%. So maximum efficiency equal to 98 by 100. 98%, 98 by 100, that is 0.98. Maximum efficiency equal to 0.98, which occurs at 80% of full load. So here when we are going to get maximum efficiency at 80%, that is maximum efficiency occurs at 80% full load, that is it is not for 100%, it is of fractional load. Okay, 80% fractional load. So fractional load X equal to 80%, that is 80 by 100, that is 0.8. At full load at 0.8 power factor lagging, that is power factor means cos phi. So cos phi value is 0.8 lagging. If the equivalent leakage impedance they have given equivalent leakage impedance of the transformer referred to primary, that is Z01. Okay, so Z01 leakage impedance referred to primary, that is Z01 value they have given. Z01 equal to 4.55 ohms. And find the voltage regulation, that is they are asking voltage regulation or at full primary load current of 30.1 amps. Of course they have given for full load current. Okay, so I load at primary is 30.1 amp. So what to find? To find out the leakage, to find out the voltage regulation. So solution is at maximum efficiency. Okay, there is a condition for getting maximum efficiency. For getting maximum efficiency, iron copper loss equal to iron loss. So WCU copper loss is should be equal to WI iron loss. Okay, so both are equal, then only we are going to get maximum efficiency. So we have to remember this. Efficiency, maximum efficiency of fractional load is X into VA rating into cos phi by X into VA rating into cos phi plus iron loss plus copper loss. Here the iron and copper loss, as it is a fractional load, the iron loss is equal to copper loss, and for maximum efficiency, so W plus WI plus WCU both are equal. So here in this, the maximum efficiency of a fractional load is 0.98 is equal to X value is fractional load, that is 0.8 into VA rating. VA rating is kVA, 10 into 10 power 3 into cos phi value 0.8 by again X value is 0.8 into VA rating, 10 into 10 power 3 into cos phi value 0.8 plus here WI equal to WC for maximum efficiency, so 2 WI. So at last the unknown value is WI. So iron loss equal to copper loss, and the total that is WI equal to after doing that we are going to get 65 watt. Okay, here WCU equal to WI equal to 65 watt for 80% load. So for full load, WCU at full load is 65 by 0.8 square, 0.8 square, because for 80% load, right? So 65 by square, okay, 0.8 square. So that is 101 by 0.56 watts. Okay, so WC value is 101.56 watt. I2 equal to kVA rating by V2, generally kVA volt amperes. So I2 V2 equal to kVA rating. So I2 equal to kVA rating by V2, that is 10 into 10 power 3 by V2 is V2 or E2. So E2 value is 5000. So 10 into 10 power 3 by 5000. We got 2 amperes. So here I2 current is 2 amperes. Next, transformation ratio is K equal to E2 by E1. So E2 value is 5000 and E1 value is 500. That equal to 10. So K value is 10. Next, here cos phi value. We need to find out the cos phi value. Okay, for getting sin phi value. So cos phi value, if cos phi value is 0.8, then what is phi value? Phi value is cos inverse 0.8. So we got the phi angle value, that is phase angle value, that is 36.86, 36 degrees 86 minutes. So 36.86. So so sine into phase angle, sine into 36.86, sine phi equal to 0.6. We got sine phi value is 0.6. Next, I2 square R02 is nothing but 101.56, 101.56. That is copper loss. We know the formula for copper loss is I2 square R02. Okay, referred to secondary. So here I2 square R02 equal to 101.56. So R02 value is 101.56 by I2 square. What is I2 value? 2. So 2 square. So 101.56 by 4, that is 25.39 ohms. Next, Z2 dash. Okay, we need to find out the we know that the leakage impedance equivalent leakage impedance referred to primary. Okay, that is Z2 dash. So Z2 dash equal to Z2 by K square. So Z2 by K square equal to Z2 dash. Then Z2 equal to Z2 dash into K square. So 4.55 into 10 square, that is 455 ohms. Next, we need to find out Z0 X0 2. Why we are finding all these things is for knowing voltage regulation. Okay, there are many terms, so one by one we are going to find out. So X02 equal to under root Z square minus R02 square, that is under root 455 square minus 25.39 square equal to 454.29 ohms. So percentage voltage regulation, the formula for percentage regulation is I2. We just find out I2 value, R02. Okay, we got R02 value also, and cos phi 2 value also we know, that is 0.8 plus I2 X02 sin phi 2 by no load rated voltage, that is secondary no load rated voltage, into 100. So here I2 value is 2 amperes and R02 value. So one by one we found in the process. Okay, R02 value is 25.39 into cos phi is 0.8 plus I2 value 2 and X02 value is 454.29 into 0.6 by 5000. Okay, no, secondary no load voltage they have given as E2 is 5000 is equal into entire into 100 for getting percentage. So we got percentage voltage regulation is 11.7 volts. Next problem we are going to see. So in the next question paper, this is BTech second semester. See, even though it is third semester, second semester or first semester, okay, the subject name BEE, okay, means the same for all the papers, and but here we are seeing basic electrical and electronics engineering. So the electrical related problems will be same for BEE and BEE. So basic electrical engineering supply and examinations of September 2023. Okay, here we are going to get some more transformer problems, that is 6B, there is a transformer problem, and 7B also there is a transformer problem. Here they have given 2 pages of question paper. So 6B and 7B we are going to see. So 6B is a single phase transformer has 2000 turns on the primary and 200 turns on the secondary. The no load current is 3 amperes at a power factor of 0.2 lagging. Calculate the primary current and power factor when the secondary current is 280 amperes and power factor of 0.8 lagging. Okay, this is the given data. So what they have given, it is a single phase transformer and has 1000 turns on the primary, that is N1 equal to 1000 turns, and 200 turns on the secondary, N2 equal to 200 turns. The no load current I0 equal to 3 amperes at a power factor of 0.2 lagging. So cos phi value is 0.2 lagging. Calculate the primary current I1 value and power factor when the secondary current and a cos phi value when the secondary current is 0. Secondary current means I2 is 280 amperes and power factor of 0.8 lagging. So they are asking primary current and power factor, that is cos phi 1 and I1, and they have given the data of secondary. So secondary current is 280 amps I2 and secondary cos phi 2 cos phi 2 is 0.8 lagging. So we know the transformation ratio K equal to N2 by N1. So 200 by 1000, that is 0.2. Okay, what is transformation ratio? K equal to N2 by N1 equal to E2 by E1 equal to V2 by V1 equal to I1 by I2. So whatever data we find, so from that we are going to find out. So here we know N2 and N1. So we are using that formula K equal to N2 by N1, that is equal to 200 by 1000, that is 0.2. Next, I1 value. What is the I1 value? Total current. The total current equal to no load current plus I2 dash current, okay, which is going in the primary. So I1 equal to I2 dash plus I0. What is I2 dash? I2 dash, the formula for I2 dash in the equivalent circuit is I2 into K. So I2 value is 280 and K value is 0.2. So we got I2 dash equal to 56 amperes. So I1 equal to 56 amperes plus I0 value. I0 value is 3 amperes. So 56 amperes plus 3 amperes, that is 59 amperes. I1 value is 59 amperes. And after that V1 value. Okay, so V1 value, V1 I1 cos, see the power factor, that is power. Okay, W1 equal to W2. So the V1 I1 cos phi 1 equal to V2 I2 cos phi 2. So we here I want cos phi 1 value. So cos phi 1 value equal to V2 by V1 into I2 by I1 into cos phi 2. Here V2 by V1 is nothing but K. So directly we can substitute K value. So K into I2 into cos phi 2 by I1. So 0.2 into I2 value is 280 into cos phi 2 value is 0.8 by I1 value. I1 value is 59 amperes. So we got 0.75 lagging. Okay. So here they have given one more problem in basic electrical engineering, that is 7B. So the EMF per turn of a single phase 10 kVA 2200 by 220 volts 50H transformer is 10 volts. Calculate number of primary and secondary turns. Number 2, the net cross sectional area of the core for a maximum flux density of 1.5 Tesla. So we have to write the given data. So this is for single phase transformer. Okay, single phase transformer, E1 value is the EMF per turn, for per turn is 10 volts. So 10 kVA. So the rating they have given 10 kVA. kVA rating is 10 kVA and E1 value is 2200 volts and E2 value is 220 volts and frequency is 50 Hz and flux density. Okay, generally flux density will be given in Webers per meter square or Tesla. So BM equal to 1.5 Tesla. And to find number of primary and secondary turns N1 and N2, and to find out cross sectional area A, you have to find out the cross sectional area. So here N1 equal to see number of turns in primary winding. How we are going to get number of turns in primary winding? That is, already they have given E1 value. E1 value means total EMF value, total voltage value in the entire primary winding. So entire primary winding means total number of turns. Okay, entire total number of turns. So total number of turns, and each turn voltage value they have given, that is 10 volts. So N1 equal to total number of windings voltage, that is E1, by each turn EMF, each turn voltage. So total winding voltage by each turn voltage, E1 by EMF per turn. So 2200 by 10, that is such that for one turn it is 10 volts, for number of turns it is 2200 volts. So 2200 by 10, that is 220 turns in primary winding. In the same way, N2 equal to E2 by EMF per turn, 220 by 10, that is 22. Number of turns in secondary is 22. Okay, here we need to find out N1 and N2. So where we are going to get that formula? Maximum flux. So generally E1 equal to 4.44 N1 F phi m, right? E1 equal to 4.44 N1 F phi m. In that phi m value we have to find out, because they have given generally the formula for area is phi m equal to Bm into A. So Bm, flux density, they have given. We need to find out phi m value. So phi m equal to E by 4.44 F into N1. So E1 by, so EMF per turn, that is 10 by 4.44 into 50. Why per turn? That is per turn voltage. If you put, no need of putting total number of windings, right? So per turn voltage is 10. So 10 by 4.44 into F into number of turns into primary winding, no need, because one turn we got, right? So by into 1, that is 0.045 Webers. And next, cross sectional area. So phi m equal to Bm into A. So A equal to phi m by Bm. Phi m means maximum flux and Bm is maximum flux density. So phi m value is 0.045 by Bm is 1.5, that is 0.03 meters square. We are going to see another question paper, BTech first semester supply and examinations, September 2023. Basic electrical engineering. So the electrical related problems for basic electrical and electronics engineering and basic electrical engineering, both are same, BEEE and BEE. Both electrical problems will be same. So here if you observe carefully, 7A we are having a problem. Okay, we will see that transformer problem. So 7A, the EMF per turn for one turn, the voltage is 10 volts of a single phase 10 kVA. So the rating of a transformer is 10 into 10 power 3 volt amperes, and 2200 by 220, that is E1 value is 2200 volts and E2 value is 220 volts. 50 H. Okay, 50 H, the transformer F equal to 50 H, and rating is 10 kVA. So here the rating is 10 kVA. kVA means that is nothing but apparent power, right? So they have given the symbol of S equal to 10 kVA, and is 10 volts. So EMF per turn is 10 volts. Calculate number of primary and secondary turns. They are asking N1 value, N2 value, and net cross sectional area of the core, that is area value, and they have given maximum flux density. They have given BM, maximum flux density 1.5 Tesla or Webers per meter square. So here if you observe, EMF per turn, for one turn they have given the voltage of 10. So EMF per turn equal to E1 by N1 or E2 by N2. That is, E1 means total number of turns voltage by total number of turns. So total number of turns voltage by total number of turns, if you cancel, you are going to get each turn voltage, or in primary or secondary. So E1 by N1 is equal to E2 by N2. So E1 by N1 equal to general formula is 4.44 F phi m, right? So E1 by N1 equal to 4.44 F phi m. What is phi m value? Phi m value is Bm into A. Okay, Bm ante maximum flux density into area. So E1 by N1 value is 10 and equal to 4.44 into 1.5 into area into frequency 50. So A value is 10 by 4.44 into 1.5 into 50, that is 0.3003 meters square. So E1 by N1 is equal to, we got all the value, that is 4.44 into 1.5 into 0.3003 into 50, right? So from this E1 by N1 means EMF per turn. From this same formula we are going to find out the N1 value. So N1 equal to E1 by the entire thing. So E1 2200 by 4.44 into 1.51 into 0.3003 into 50, that is N1 value is 22 turns. So E1 by E2 equal to N1 by N2. So here we are going to find out N2 value also. Now we find, this is another way of doing a problem. So E1 by E2 equal to N1 by N2. So N2 equal to N1 into this left side, E1 by E2 will go to the right hand side and becomes E2 by E1. So N2 equal to N1 into E2 by E1, 22 into 220 by 2200 volts. So N2 value, number of turns value is 2.2 turns. See, we have to write the round figure for number of turns in primary or number of turns in secondary. It won't be there in decimal values. So instead of writing 2.2 turns, a round figure of 3 turns, like that we have to write. So N2 value is 3 turns. So thank you very much. We have completed. See, if this problems and this data is very much useful to you, please like, share and subscribe. If you share to many persons, it is encouraging for me to do more such videos. Thank you so much.